Hey everyone, welcome back to Scalar. Today in this particular video, we will talk about building chains in LangChain. But before we get started, make sure you subscribe to the channel so you don't miss the rest of the Agentic AI playlist. And if you are serious about building a strong career in AI, check out Scalar's Advanced AI and Machine Learning program, co-certified with IIT Roorkee CEC. It's designed to help you master the skill needed for the real-world AI role and get you ready for that. For more information, check the link in the description box. Also, tell us in the comment what other AI topics you would like us to cover. So let's get started. We are going to talk about two very important concepts. First of all, we will talk about the parsers. Now, I hope all of you understand that when we prompt a particular LLM, the output that we get is a text output which can have any kind of structure. So let's say if I ask my LLM, well, what is the capital of India? Now, LLM might answer you with one sentence. The capital of India is New Delhi. Or LLM might answer you with a sentence plus a paragraph about New Delhi. So you cannot restrict the LLM to produce the output which is as per your requirement. And when we are going to talk about agents, when we are going to build some agents, it is very much important that we generate the output out of the LLM in a structured format. And that is where the concept of parsers and structured output plays a very important role. Additionally, in this particular video, we will also talk about the concept of chains. Now, as I have discussed in the very first video and the second video, that when we work with LangChain, LangChain has given us a very great power that it can help you form chains. Now, what is a chain? So, the output of a previous stage can automatically become the input to the current stage, and that is how you can form endless chain. Now chain can be either sequential, which is the input output, then input output, then input output, or chains can be conditional, chains can be parallel, chains can be also in multiple forms. So in this video we will talk about how we can create all these kinds of chain together with the concept of parsers. Now, all these concepts or both of these concepts will go side by side. So I will be talking about parsers, then I also be showing you the implementation of chains. So these two concepts will go side by side. So without wasting more time, let's get started. Now here you can see that I have created the basic setup, which we will be doing in almost all the videos. So whenever we start, we have to set up our environment variable where I have preserved all my secret keys, the API keys in this particular environment variable, which is .env file. I am installing some important packages such as LangChain Core, LangChain OpenAI, LangChain, LangChain Anthropic, Community, and ChromaDB. We will not be using these two, so I can delete them. I have also installed the library which is LangChain Google Gen AI. Now, this is something which will help us to use the Gemini model from Google. And then this is something which we are going to talk about today, which is Pydantic and Pydantic email. Now, before I start, I want to tell you that Pydantic is not related to LangChain and Pydantic is not related to LLMs. So Pydantic is basically a powerful framework which comes in Python that helps you enforce type hints at runtime. And what is the meaning of type hint? So if I use Pydantic, I can enforce a schema on a particular output. So if you want to make sure that your LLM generates the output, which is exactly what you require, we can use this particular library, which is Pydantic. And I will explain you everything about how to write a Pydantic object and how to use it. So we will first of all simply install it, and you can see there is a green mark which basically means I have already installed it. Now I'll simply write from Pydantic I want to import the base model. Now, this is something which you will be required to do every time you want to use a Pydantic object, because we are going to create a class which is going to inherit with the base model. I will create a class, and this is the procedure that we will be following in every structured output, or every time I want my LLM to generate a structured output. So I'm going to create a class which is, let's say, named as user, and it is going to inherit to the base model. Then this particular class will, so we will define the variables and their respective output. So I need a variable ID which will be of integer data type, then name which will be of a string data type, then let's say sign up date, sign up, let's say TS timestamp, which is going to be in date time format. And I am going to also load from this library. So from date time, import date time. So this will, now if you want to make something default, so for example, if someone is not providing the sign up timestamp, I can also place it with a none. So none is basically the default value. This is the default value. If the output or if the input is not provided, I know you guys must be getting a lot of confused right now. So don't worry. Let me complete this and then I will show you the magic. Age is a optional class. So for optional, from typing, I will import the optional optional class. So I will use optional over here, and this is optional integer. And again, there is a default value none, right? And then I will also add email. And here for email, I from the Pydantic class itself, I will use email str. Now, email str will only be working when you install this particular sub part of the library, Pydantic email. So email str comes with all those validations which make sure that the input which is provided by the user in this particular category, which is email, is following all the validation of a proper email. So I am saying email str. And let's now execute this by defining a dictionary. So let's say my di is equal to, I'm defining a dictionary with id which is integer. So let's say 1 2, then comma, defining the name which is, let's say, Sumit, then comma, I'm defining the sign up TS. And right now what I'm going to do, I'm going to leave it, or let's not define it, because we have already defined it as none. So I am not going to define it as of now. Age also I'm not going to define it. And for email, let me define it with some email which is wrong as of now. So let me put an email such as Sumit. Now what I'm going to do, I'm going to validate this with the user class which I have created. So user, and this is how I provide the input to this user, star star di. Now if I run it, you will see that I'm getting error, validation error. One validation error for user, email. Value is not a valid email address. An email address must have a @ sign. So if I make this, let's say @gmail.com, I should be able to run it. And you can see that sign up is none, age is none, email is this. Now, what we have done is we have created a Pydantic object, and this Pydantic object is now, so this is a Pydantic class. Let's create an object user. Now, this is a Pydantic object which is now capable of only accepting the data in this dictionary which follows these rules. So now what is the advantage of this? If someone is describing a dictionary and you are passing that dictionary to this Pydantic class, which generates a Pydantic object, you are automatically able to validate all the keys and their respective values. That is what the advantage of Pydantic is. And since this is a Pydantic object, so let me run it. You can actually call this, or maybe you can work with it similarly by using the various keys. So for example, user.id will give me this, user.name will give me my name. So you can work like this. So this is what the advantage of Pydantic is. Pydantic is very much helpful to make sure that you are able to enforce a schema, and also you are able to validate the schema. So both the advantages are provided by Pydantic. As I have mentioned before also, Pydantic has nothing to do with LLM. Pydantic has nothing to do with LangChain. Pydantic is an external way in Python to validate the schema and to validate the inputs. That is what Pydantic is. So if I am making someone to enter their detail in a form, you can assume that Pydantic is a way to ensure that all those inputs are validated in the runtime. And that's what the advantage of Pydantic is. Now let's talk about why we are so much worried about the output structure. So when we talk about LLMs, we have two kinds of LLMs. So some LLMs are those which are capable of generating a structured output. So they are tuned. So for example, if I talk about OpenAI, or if I talk about Gemini, they are trained in such a way that they can simply generate a structured output. They can generate the structured output. But there are some LLMs which are open source LLMs where they are not trained to generate a structured output. So in this particular case, number one, we can use the with underscore structured underscored output. So we can use this particular class, which is with underscore structured underscore output, while I am going to invoke these LLMs. But for open source, I need to use the output parsers, which can make sure that once the response is generated by the LLM, I am able to parse the output in the structure that I want. So I am going to show you both the methods, but the advantage is that these output parsers are very much compatible with these well-trained LLMs also. So this with structured output is not compatible with these open source LLM like Llama. But if you're talking, and if we are talking about the output parsers, which we will be talking about, these output parsers are very much comfortable and compatible with either your well-trained LLM, which are OpenAI, ChatGPT, or Gemini, or Mistral, or any kind of LLM, which are very well maintained and trained, or even with the open source, which are not so well trained, which are your Llama or Tiny Llama. So we are going to talk about both of them in very detail. Let's start with the very first one, where we are going to get a structured output using with structured output. Now before that, what I'm going to do, I'm going to take some reviews from a Amazon product. So let me just copy this link. This is the web page link. And what we are going to do, we are going to first of all do a quick scraping. So I'm going to write a request class. I'm going to write a request function, and that request will help me get all these reviews from the this web page by scraping it. And we are going to create a list of all these reviews in a Python list. I'm going to copy paste the code, but since the objective of this video is not to teach you about web scraping, but you can check out my one of the videos which I will pin in the I button on how to scrape. So basically I'm using the request library, which is going to help me connect with this web page. While I'm requesting it, I'm also sending the header, which is my user agent, the kind of text I will be accepting, the language and the referrer. Together with that, this is the URL, and using the beautiful soup library to convert this particular output HTML in a structured HTML, so that I can do some kind of searching, because I need to search. So basically, if I go and open the inspect cell, I need to search. So let me show you. So these are the reviews. I have to go to this section. So I need to go to this section. Within this section, want to go to this section, and within this section, I want to go to this section. Within this section, I will expand this section, then this section, then within that, this section, finally this section, and this section. So here we have the review. So this section, and let's open this one also. So here you can see I have a, no, I don't have a review over here. So I need to go a little bit more deep. This one. So here you can see we have the actual text. And in order to reach to this point, the particular division is data hyphen hook and review collapse. So this is something which I can simply do by using beautiful soup. So let me just copy another piece of code. So this piece of code, what is it is going to do? It is going to find all the divisions where the tag is data hook and the sub tag is review collapsed. And as I showed you, that this is what I am willing to find out: data hook, the class, and the value is review collapsed, so that I am able to get these reviews, because my objective is to get all these reviews so that I can query with the LLM, can get some structured output. So let's run it. Let's see if we are able to do it. Now you can see we have the list of all the reviews right over here. Now what I'm going to do, I'm going to create a Pydantic class. So from Pydantic, I want to import the base model, and I will also import the field. Now why I'm importing this field, I'll tell you now why this is important. Pydantic, spelling is wrong. Pydantic, okay. Also from typing, I will import literal, and let's write the class Amazon. This class will inherit with the base model. I just want first the summary, which will be in a string. And now using this field, I will describe, so I will be able to add a description. Now, this description is very much important for my LLM, because my LLM will use this description to understand what is the output that it has to fit in this particular tag, which is summary. So let me write the description: a short summary about all the reviews. Then I don't need to put a comma because this is a class. Sentiment. Now, sentiment is going to be a literal. It is a literal, and there will be three sentiments: positive, then comma, negative, and neutral. Again, Google Colab has helped me to autofill it. So field will be description, the sentiment of the review. Okay. Let's say I also need to enter review count, the number of reviews, and let's say final verdict. So final verdict is also going to be a literal, and this literal will be either by or not by or simply not sure. Also, we can add one more thing over here, the sentiment of the review, which is either positive, negative, or neutral. And here also we can write that this is a field, the final verdict based on the reviews, either by, not by, or not sure. Okay. So this is also done. So my Pydantic class is created. Now I'm going to initiate my Gemini model. So from LangChain underscore Google underscore Gen AI, I will import chat Google generative AI. I'm going to instantiate it with chat Google generative AI, and here I will not play with the temperature but the model. So my model is going to be Gemini hyphen 2.5 hyphen flash, and then my structured gem. So structured GM s underscore GM is going to be GM dot with underscore structured underscore output Amazon. So this is the change that we have done. So we have instantiated the Google chat model, which is Google generative chat Google generative AI. And then we have added this particular Pydantic class, which has the enforced schema with this particular method known as with structured output. And we are working with the Google chat model. Let's run it. And now I will simply say s underscore gm dot invoke, and I will pass this particular list of reviews. Now my output needs to be a structured output. So let's run it and let's see the result. Now this is my result. Now this is a Pydantic object. Amazon, this is a Pydantic object. I can convert this Pydantic object to a dictionary. So this will be a Python dictionary. And here you can see summary, the Philips nano product filter is highly effective, sentiment is positive, number of reviews are 11, final verdict is I should buy it. So this is what the advantage of the with structured output is. And the reason I am able to use this with this Google Gemini model is because this particular class, which is chat Google generative AI, is a well maintained model which inherently comes with this functionality. So while someone or while the Google trained this model, they also added this capability to this model, that this model, when enforced with some kind of schema, is capable of generating the structured output. So that was the advantage of with structured output. And believe me, you can use this with structured output with either your Claude or your OpenAI, which is ChatGPT, and even your Grok and even your Gemini. So this is very good for creating structured output. But the main problem comes when you are working with those models where this kind of method is not available. So that is where LangChain has provided you some output parsers. And that is what we are going to talk about now. So now let's talk about the output parsers which are provided by LangChain. The very first output parser is the string output parser. And the task of these parsers is basically to extract or basically parse the textual output from the LLM to something which is enforced schema. As of now, my words might be sounding very strange to you, but don't worry. We will sequentially talk about everything. And by the end of the video, I will also summarize everything, which will make everything very clear to all of you. With the introduction of structured output parser, I will also introduce the concept of sequential chain also. So here I will just add plus. We are also going to talk about sequential chains. So these are the two things which we will talk about simultaneously. Before I proceed, I just want to recap very important part that is of Pydantic. Remember one thing, Pydantic has nothing to do with your LLM. Pydantic is a Python way to enforce a schema in runtime. And here you can see that when I created a dictionary, I can quickly enforce a schema and validate using this particular Pydantic class. That is what we are doing over here also. We created a Pydantic class, and while invoking the Google generative AI model, which is Gemini, I created the with the structured output LLM, which is basically enforced by the Pydantic output or Pydantic schema. And now every output that will come out of this particular model has to be enforced or has to be validated with this schema. So this Google generative AI, which is Gemini model, is well capable enough of making sure that when it is getting invoked together with this schema, it is able to generate your output with this schema, and it is able to follow all the rules and instructions. So this was the use case number one. Now, a structure output parser is basically once your output is generated by the model, then how you can parse it. So structured output parser is basically the easiest parser. It has very simple task. Let me show you. First of all, I'll copy this. I'm creating a Gemini model GM, and then from LangChain underscore core dot output parser, we are importing the structured output parser, and then we are also instantiating it with st. Now what I'm going to do, I'm going to invoke my gm dot invoke with a question. The question is, who is the PM of India? It will give me a result, and let's see the result. So here we have the current PM of India is Narendra Modi, and this is basically the output. Now, as we have learned that if you want to just check or get the content, all you do is you basically write content over here and you will be able to get the content. I am really sorry, you write dot content, right? So this is basically the output. But there is another way of getting this done. What you can do is you can use the structured output parser, which is a string output parser, to automatically get this particular content extracted from the output generated by this particular LLM. Let me show you and then I will explain to you what I'm trying to say. So let me first of all create a template, a prompt template. So for a prompt template, let me quickly get the function. So from LangChain underscore core dot prompts. I want to import the prompt template. I'm creating the template number one, which is prompt template. You don't need to use this now. And prompt template takes two inputs. Number one is the template. Template is, so let's not use this. I'm just simply asking, what's the capital of, and let's say the template has a input variable, which is, let's say, country name. Then here I need to also define the input variables, which is country name. And let me close the bracket. And now if I say tem1, then gm, then st. Now what is happening over here? This is basically what a chain is. And this pipe operator has a very special name known as LCEL, which is LangChain expression language. Now, this is exactly what and how a sequential chain looks like. One second, why it is showing me error? There is a bracket over here which is wrong. Yeah, now it should not. Yeah. So this is how we create sequential chains. We have a particular class which is known as the runnable sequential, which we can use to create sequential chain. But here I'm using a very innovative method which is described by LangChain to use this pipe operator. And pipe operator is in turn enabling me to use the sequential runnable or sequential chain. Now, how this chain is working? First of all, I will provide this chain or invoke this chain with an input. That input will first go to my prompt template to create a dynamic prompt. So let's say I have provided the input. Let me write it. So I'll simply say chain.invoke, and I will invoke it with the dictionary country name India. Now this particular input will go into temp1 over here, which is basically the prompt template. Prompt template will help me to create a dynamic prompt. So this input India will be enforced over here to generate what is the capital of India. The output, so the entire prompt, the dynamic prompt will go to my Gemini model and it will generate the output. Now this output will be parsed by the string output parser, and this is what I will get, the only the content part. The advantage of using a structured output parser is that now I don't need to explicitly write this. And I will show you how it makes more sense when I will show you a more complex chain. But as of now, I just want to run it to show you the output. And here you can see the capital of India is New Delhi. And here I have not written anywhere this particular piece of code, which is result.content. Neither I have preserved the output in a variable result, nor I have written result.content. But still, I am able to get the content part of this output from the Gemini model because of this string output parser. But why we need this? We need this because as soon as I create a sequential chain where this output is getting utilized in another input, then structured output parser makes a lot of sense. So now what I'm going to do, I'm going to create another temp, which is the prompt template. And let me do one thing. What's the, or maybe write 5 points about why should I visit this city. And here I will use this particular input. So here I will provide city name, and here let's change it to city name. Now what I'm going to do, this output, which is the capital of India is New Delhi, I'm going to use it as it is as the input to my temp2. So let me just add one more pipe operator and temp2. This will go inside my another Gemini model, and I will again parse my output. Let's run it. And here you can see that I have the output. Here are 5 compelling reasons why should visit New Delhi. So here you can see that it has simply understood that I am talking about New Delhi. I'm basically talking about New Delhi, and it has written the 5 reasons. So if you print it, you will be able to see this output in a better way. But here you can see we have 5 points why I should visit this city. And the city is something which I'm getting from the previous output of the Gemini model. So first I invoked this particular template to generate the dynamic prompt with the country name India. So it generated the prompt, what's the capital of India? That I invoked to my Gemini model, which returned me the output. And the output, as you know, consists of so many parameters. So the string output parser got invoked to basically generate only or extract only the content part. Using that content part, I again invoked another prompt template to create a dynamic prompt, which I again invoked to my Gemini model. And again, that output got to the string output parser to extract only the content part. This is the advantage of the string output parser. So though it looks very simple, that string output parser is all it is doing, is basically something like this. But the advantage of string output parser comes when you create sequential chain, and this is very much helpful. Now, I also want to add one more very important thing. When you create sequential chain, the reason I'm able to invoke all these elements of my chain one after the other without invoking them individually is because all these methods, or all these, I will say, components of my chain, all of them are getting executed with the same method, which is invoke. So I can invoke this also. If I write temp2.invoke, I'll be able to generate the dynamic prompt. If I want to work with Gemini model, I can say gm.invoke. If I want to work with the structured output parser, I can say st.invoke, again tm2.invoke, gm.invoke, st.invoke. So all of them, since they are working with .invoke method, I am able to invoke all of them one after the other without invoking them individually. So there is one more name given to each of these components. They are known as runnables. I will talk about in detail about what a runnable is, but each one of them is a runnable in LangChain, due to which I can put them in a chain to invoke all of them at a time, or invoke all of them in one shot. That is what the advantage is. Now let's talk about JSON output parser. So we have talked about string output parser, and we also learned of the concept of sequential chains using LCEL. Now let's talk about the concept of JSON output parser. So JSON output parsers. Now again, let's get the JSON output parser from LangChain underscore core dot output parsers. I need JSON output parser, not function. And then let's create a JP. So instantiate the JSON output parser. Let's create a prompt template. Now what you are going to do is, when you're creating a prompt template, um, you will create first of all the template where you will provide the instruction. So let's say the instructions are, give the capital, the GDP, and the population for following country. And here I will mention the country name and the input variable is country. Now, one thing which I'm going to do over here is I'm also going to enable one partial variable which will have the input as format instructions, which I will add over here with a new line. So slash in format instructions. Now, what is going to happen? So let me just remove this as of now and let me invoke 10.1 dot invoke. So what is the country name, right? Country name, and the country name is, let's say, India. What happened? Oh, I have not closed this bracket. Now, the invoked prompt is give the capital GDP population of the following country, India. So India is getting replaced over here. And this format instruction is getting replaced with this return a JSON object. Now, how this is coming automatically in this particular prompt? This is coming because here I have defined a partial variable. Now, partial variable is something which is not provided as an input by the user. What we provide or the user provide as an input is described inside the input variables. But what the prompt internally invokes is basically the partial variable. So partial variable is basically the prompt for format instruction, and format instruction will be filled with this particular instruction. So from where I'm getting this instruction? From JSON output parser. So JSON output parser is helping me with some instructions that I can provide to my LLM while I invoke the LLM, so that the output is generated as a JSON output parser, and then this can be parsed as a JSON object by the JSON output parser. So let me show you now. Let me write the chain. So C is equal to, first of all, I will get the temp. It will go to my Gemini model and then finally go to the parser JP. Let's invoke it. Here you can see we have a JSON output. We have country name India, capital New Delhi, GDP nominal USD is this, population is this. So this is how you can use a JSON output parser. But there is a very big problem. And I hope you guys would have identified this problem. And if you have, then please pause this video and write down what you have understood. Here you can see that though I am able to get the output in a JSON object, this JSON object is not following any kind of schema. And that is where I need to enforce the schema also. So how we can enforce the schema? We can use the Pydantic output parser. So we have JSON output parser, which will make sure that I'm getting a JSON object. And in Python, JSON object is basically your dictionaries. But here, the JSON output parser is able to generate the dictionary object, but that dictionary object is not following any kind of schema, the structured schema. We are not able to make sure that I'm getting capital, only the capital, the GDP in rupees and population. It is giving you country also, GDP nominal USD and population. And we are not able to enforce the schema. So now let's talk about the Pydantic output parser, which allow us to enforce the schema. Pydantic output parser. So now when we talk about Pydantic output parser, again from LangChain underscore core dot output parsers, I will import Pydantic output parser. From Pydantic, I will import the base model and the field. Now let's create a class, maybe country. This will inherit with the base model. First will be the capital. Capital will be string, and I will define the field in the description. Description would be the capital of the country provided by the user. Then it will get GDP. GDP, I want it in integer, which is going to be in, so field is described, so description, and description would be GDP of the country in rupees, in INR, provided by the user. Then population. Population, again integer, field, description. चलो ये हो जाएगा. So this is also done. Now what I'm going to do, I'm going to create a Pydantic output parser, and the Pydantic object is this country, right? So this is my Pydantic output parser. Now what I'm going to do, I'm going to now create the template. So let me just copy this template. And while I'm copying this template, I'm going to use this p dot get format instructions. Now what will going to happen? So if I say temp dot invoke country name India, just see the output, how the template has got invoked. Where are the format instructions? The format instructions starts over here. Here is the output schema. Properties, capital, description, then something something. So here you can see it has added a detailed instruction for the LLM to make sure that it is generating the output against this particular described schema. Let's create the chain. C is equal to, first it will go to temp, then G, then P, which is model, and then the parser. And parser should return me a Pydantic object. So let me write C dot invoke. I'm going to invoke with country name India. I'm going to preserve the output in the result, and let's run it to see the result over here. So result is capital New Delhi, GDP, and population. If I convert this into a dict object, you will be able to do it because this is a Pydantic object. Now you are able to enforce the schema. So we talked about three parsers. One is the string output parser, which is not doing anything amazing. It is just basically capturing the content part from the AI output. So from the entire AI output, it has extracted the content part, but it is very much useful when you create sequential chains where the input to the next step is the output from the previous step. JSON output parser, which can help you to make sure that the output is in the JSON object, but this will not allow you to enforce the schema. So we use Pydantic output parser, which will allow you to make sure that you are able to enforce the schema also, and you are able to get the output in a very structured format with the description of various keys that you have defined in the Pydantic class. Now let's talk about the two very important chain, which is the parallel chain and the conditional chain. So we will continue the discussion on the chain part. We have already talked about the sequential chain using LangChain expression language. This is sequential, but how we create parallel and conditional chain, we will talk now. So before we talk about the parallel chain, let me show you the structure. So let me open the TL draw and let me show you the structure of how this parallel chain would look like. And I will recommend all of you, whenever you are willing to create any sophisticated chain in LangChain, it is a good idea to always draw the entire workflow. So what is going to happen is I'm going to create two chains, and both the chains are going to do some task for me. This first chain will take the input from the user, and the input will come to both the chains from the same invoke function. So when I say invoke, I will get the input to both the chains. This chain will tell me the capital of that country. Tell the capital of the country, and the country is basically the input that I will provide. And this particular part tell me 5 points on why should I visit this country. And again, the country is the invoke. I'm going to create another LLM, or basically the chain over here, which will take this, which will take this. This will simply combine both the things. So again, this is the chain, so it will be going to combine, but you can think of any other complicated use case also, but as of now, demonstration purpose, we will combine. We will pass it to the string output parser and we get the output. So this is what the chain we are going to work on. So both these sub chains are going to execute parallelly. That is the reason we are going to call the runnable parallel, because we are going to run two chains parallelly. So let's start. I will first of all from LangChain underscore core, I'm going to call runnables. And from the runnable, I'm going to create runnable, not pass through. So we will talk about pass through in the next video. I'm going to import runnable parallel. Now I'm going to create tem1, which is the prompt template. And this prompt template, what's the capital of the country? So this is correct. I'm going to create another prompt template. Yes, so this, why should I visit this country, not city? Because here I'm going to invoke country, and here it will be country name and input underscore country name. So this is also done. Now let's create the third prompt, which is going to take both of them and combine it. So prompt template, combine the text and summarize together in 50 words. So here we have text 1. Let's call it as text 1. And let me add a new line over here. So slash n, we have text 1, then other slash n, we have text 2. So here we have text 2. In the input variables, we have text 1. Also, we have text 2. Now remember, this over here, which is the placeholder, should exactly match this particular input variable. Yeah, we are done. A structured output parser is required, so let me just simply call it. We have already loaded it, so structure string output parser, so we'll be able to use it. Now I'm going to create the parallel chain. So p chain is equal to, we are going to create the parallel chain using runnable parallel, and runnable parallel takes your entire input in a dictionary like this. The dictionary will have the input text 1, and then the chain, which is temp1 gmst. Oh, I don't need this. Now, please remember one thing. The output of this particular chain gets preserved in the variable text1. And since I'm going to use this particular prompt template as the sequential prompt template, this text1 should match this. Let me complete the chain and then it will make sense. So my final chain is equal to p chain, then temp3 gm and st. Now what is happening? When I invoke the chain with the country name India, it will first go to the P chain. Now P chain will take the country name India and will invoke both the chains simultaneously with the same input country name, because both the templates comes with the same input variable country name and country name. So I will create the very first prompt template. What's the capital of country name India? That will go inside this. It will invoke my model and structured output parser will generate the output, which gets preserved in the text one as a key. This particular chain, the sequential chain, will also execute parallelly. So country name will go inside this. What's the what write 5 point about why should I visit country India? This will go to the model and structured output parcel will generate the output and preserve it in the text2 key. Now this entire dictionary with text1 output from the structured output parser, text2 from and the output from the structured output parser, this entire dictionary will go inside the temp3. Temp3 is over here, where text1 will get replaced over here, text2 will get replaced over here, and where the text1 is coming from here, where the text2 is coming from here, and that will create my prompt template which will go to my model, and the structured output parser will get me the content part. So let's run it. So this is how you create the parallel chain, and it must be looking very simple right now. So let's run it. And here you can see New Delhi is the India's capital. Visit India for its this, and you are able to see the output, right? So it is easy, but make sure you are able to connect the components properly. That is the magic, right? Now let's understand how to create the conditional chains. So in the conditional chain, how the structure would look like. So we already have the review, right? So what I'm going to do, I'm going to pass my review list, which is what we have extracted from this particular Amazon web page. So I'm going to pass all those reviews to my first chain, and this chain will return me either positive or negative. If it returns me positive, I will execute a chain which will again take the reviews, and will generate 5 points based on the reviews about why should I purchase this product. If the output from this first chain is negative, then I will again invoke another chain which will take my reviews again, and again will return me 5 points. Oh, 5 points regarding why should I not purchase this. So here we will have 5 points. Why should I purchase it? So this is what I will get over here. And here it will be why should I not purchase it. So I'll just add not over here. So here in this chain, you can understand one thing, that this is a conditional chain, which basically means based on the first output, which is either positive or negative, this entire chain will execute. Either this part of the chain will execute or this part of the chain will execute. So let's try to design this, right? So again, there is a necessity in this chain. This chain has to be generating either positive or negative base, which basically mean this first chain has to be enforced with a schema so that I only get positive or negative, nothing beyond that. So that is very much important. I cannot simply prompt my model to generate positive or negative, because it might generate positive with something written additionally with the term positive, but I want my model just to generate positive and just to generate negative, nothing more than that. That is where the Pydantic output parser will play a very important role. So let's create it. So first of all, I'll create my parser. P is equal to my Pydantic output parser, and my Pydantic object is basically, let's call it as Amazon review. So I'm going to also describe my Amazon review over here. So class Amazon underscore review, and it is going to inherit with the base model, which I have already loaded in the previous over here. So we'll not need to load it again. Let me do one thing. Let me write it this be after this, so that first we create the class. So it will have the sentiment. Sentiment is going to be literal. So literal is also already imported, so I don't need it. Literal, positive, negative, neutral. The sentiment of the review, either positive, negative, neutral. So this is done. This is also done. Let's create the prompt template, tem1 prompt template. And this prompt template will have the template. What's the sentiment of the funnel review? Format instruction. My input variable review and format instruction is p dot this. So this is also correct. This is also done. And now let's invoke. So C1 is equal to temp1 pipe operator goes to Google Gemini model and then P. Let's run it. 1 second. The problem is, what's the problem? The problem is I have not invoked it. So let me invoke it and this, let's see where am I making a mistake. Literal is positive, negative, neutral, sentiment. Okay, this is wrong. Sentiment. So sentiment is okay. Let's see. C1 dot invoke. I'm going to invoke it with a dictionary. The dictionary will have the input as review, and review I'm going to provide this one, clean text. Okay, so let's put it over here and let's see if I am able to run it. Great, I'm not able to run it. Why? Field required type missing, input, this is this, Amazon review type dict. Okay, so let's try to decode it. What am I missing? I have created a class which is Amazon review. Okay, AMAZON underscore REVIW. So spelling is also correct. Pydantic object. Okay. Here you can see a spelling mistake. Pydantic object. I hope now I should be able to run it. I hope so. Yeah. So here you can see that the output is sentiment out positive. So this is a Pydantic object. And if you want to query the Pydantic object, you have to use the dot method. So if I say dot sentiment, I should only be getting positive. So my output is now positive, right? But this is not what my objective is. So we have generated this piece of my chain. Now I want this chain, I want this chain. So let's do that. So I will create my another template, temp2, where I'm going to write a prompt template, write 5 point about why should I purchase this product based on the following reviews. And here we have the reviews. Together with that, I don't need the format instruction, so let me just remove this. Reviews are over here. Let me close this comma. I need input variable, which is review. Great. Let's create temp2 also, which is a simple copy paste. And here write 5 point about why should I not purchase this product based on the following review. And this is also done. Now let's create the parallel chain. So we will use the runnable parallel. So I need to import that also. We have. But here I'm not going to create a parallel chain. Here I'm going to create a conditional chain. So for conditional chain, we use runnable branch. I want all of you to understand one thing, that we are going to talk about runnables in the next video in a more depth and in detailed discussion. But as of now, runnable are something which allows you to come up with multiple kinds of chain. One such chain is runnable parallel, which we have already seen. Another such chain is runnable branch, which is basically enabling you to create conditional chains. Now, runnable branch takes input as a tuple, and there are three essential tuple: tuple 1, comma, tuple 2, comma, tuple 3. Tuple 1 will execute when I get a positive review. Tuple 2 will execute when I get a negative review. Tuple 3 will execute when I don't get either positive or negative. So when neither of them is, basically, what if I am getting, let's say, neutral? In that case, this will execute. So I want to execute this tuple when I get positive. So I'll write lambda. Now this is how we write it: lambda x colon x of sentiment is equal to positive. Then I want to run temp2 gmst. So basically, if you read it properly, I'm saying when the sentiment is positive, run this chain. That is what you can understand as of now, but I'll explain you in detail also. Let me just copy this again, put it over here, and let me put negative over here, negative. And now the third default chain is basically neutral. Now you cannot simply put a neutral like that. Here I need additional runnable, which is known as, Acha, I have done a mistake over here. I was importing a runnable branch and then I should use this. That is the reason I was thinking why I'm getting a red sign. Okay, anyways. So we have created runnable branch with this branch executing when I get positive, this branch executing when I get negative. The third branch is the neutral. If the output is neither positive nor negative, then I want this branch to should execute. But this branch has to be a runnable, has to be the part of the LangChain infrastructure. And that is where I will use the runnable lambda over here. Runnable lambda. Now, runnable lambda will basically convert a Python lambda object into a runnable object, and runnable objects are very much compatible in the LangChain framework. So whenever you are creating a chain, it should be a runnable. And since here I want to put a Python lambda object, I need to first convert into a runnable object and then I can use it in my LangChain. So let me show you how I'm doing it. I am just simply saying runnable lambda, and this will take my lambda function of Python, lambda x colon simple neutral. So basically now this is also a runnable which will execute when, if this is positive, if this is negative. So if I get positive, I execute this runnable, negative, I execute this runnable, neither of them, I execute this runnable. So this is my conditional chain. Now let me create the final chain. The final chain basically which is combining this with these two. So when I create a proper final chain, first I will start with C1, then pipe operator. Now to execute this particular conditional chain, it is not simply like putting B over here. The reason is if I put B, I am not able to execute my parallel chain with the review as also the input. So this temp2 also need your input review, right? As you can see over here, that first of all conditional chain requires the output to be positive, then it will execute this with this input review. So in order to make sure that I'm able to do that, here I will create a runnable lambda, and runnable lambda will take a lambda object. I have two inputs, X and let's say review, or let's call it as R, X and R. And this R is equal to basically the clean underscore text. Then my output is a dictionary where the sentiment is X dot sentiment and review is all the review, which is the R. And let me remove this as of now. I'll show you that. Let me remove this also. So let's focus on this part only so that we can understand. So I'm creating a lambda object. First of all, you can focus on this internal part. I'm creating a lambda object. The lambda object in Python takes two input, X and R. These two inputs are basically, so one input is coming from your previous output. So the previous output is your Pydantic output, right? So previous output is coming and get preserved in X. R is getting the input from clean text. Now I am creating a dictionary. This dictionary takes the X over here, which is a Pydantic object. From the Pydantic object, I'm dot sentiment. I'm taking out the sentiment. So this will be either positive or negative, which I'm able to use over here, right? Additionally, the review which it requires over here is over here. So review is R. What is R? R is clean text. So this particular piece of runnable will enable the proper input for my branch, which is conditional branch. So let me now put a B over here, and this has completed my chain. So I'll just now simply say chain dot invoke, and I will invoke it with my review, but I want to provide all the reviews. So let's run it. Let's see. I hope it runs. Everything is written correctly. And let's see if the output is correct or not. So it was a positive review. And based on the provided review, here are the 5 points why you might not want to purchase this. Okay. Now that means it has executed a negative part. That is weird. Let's do one thing. Let's also see the output. First of all, let me print it properly, and we can preserve the output of C1 Oh, let's so it is negative, but it was positive, right? Previously it was a positive review, now it is saying it is negative. That means here it is doing some mistake, or we are doing some mistake. First, let's run it. Let's see. We'll run it with a print command so that we can read it properly. So this is Aja. Now it is overwhelming positive. Based on the provided review, which are overwhelming positive, find reason not to purchase. There is some. Oh, okay, 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 okay. Guys, there is a mistake. I have written temp 2 and temp 2. So both are getting temp 2. That's a mistake. So temp 2 and temp 3 over here. 3 should execute when I should not. So 3 is over here. Yeah, the mistake. Let's run it now. I should get the right result now. Okay, here are 5 points why you should purchase this product based on the review. Now it is correct. ठीक है, so guaranteed authenticity and high quality. Multiple reviewers confirm that this is a genuine Philip product, not a duplicate. So you can see that these are summarized based on the reviews, and because the review was positive, this particular conditional chain got executed. So I hope you guys enjoyed watching this video, and I hope you were able to understand the concept of number one, Pydantic, which helps you to enforce the schema on the runtime. Second, very important thing which we talked about was with structured output, which I can use to invoke my well-trained LLMs while I'm invoking them. And we can also provide them with a schema also. Then we talked about various parsers, which was a string output parser, JSON output parser, and Pydantic output parser. And then we talked about the sequential chain, parallel chain, and conditional chain. So this was all about this particular video. I request all of you to please mention your comments in the comment section about how this series is going on. So we have completed 5 videos in this series, and I believe I have given you enough knowledge to start experimenting. Maybe you can start creating small projects on your own. I would be very much happy to read your all your comments and the feedback about this series. Also, the next portion of this entire series will comprise of runnables, which is the next topic. We will be also talking about the concepts of RAG, where in RAG, which is retrieval augmented generation, we are also going to talk about a variety of concepts like how the text splitters are working, then how we are using various kinds of retrievals, and what are the vector databases which are available. So we are going to talk about a lot of topics now, and by the end of this series, we'll be also creating AI agents using LangChain. So let's see you in the next video. Till then, keep enjoying and keep learning.